opposite the 40. So fx equals f sine 40 and fy equals f cosine 40. I think this is the first time you're seeing this trick in one of our assignments where you go ahead and substitute in for what the components would be. But when we do this, when we have this here, we've added two more equations. But when we plug this in up here and have f sine 40 and plug this in here and have f cosine 40, now it's just f. That's just one variable at that point because we know the angles. So now it becomes two equations, two unknowns, which you can solve. So that's one approach. Just plug this in here. So just take this and plug it in here. Take this, plug it in here. And then two equations, two unknowns. I'll leave the solving to you. That's it for that first approach. The other way you could do this, okay, without having to do all that, is just relate the x to the y. So tan theta, here's my theta, equals the opposite, fx, over the adjacent, fy. So tan theta would equal fx over fy. That's the other thing you could use. So fx equals fy tan theta. I could put that in here, and again, you'd very quickly have two equations, two unknowns. Eventually, I'll do problems like this in class when we're in second semester in electricity magnetism. There's a couple where I like doing this, but this is the equivalent. This will still get there. And mathematically, if you can see it, at some point here, you're going to get a sine over a cosine, which is tangent. So it does, either approach will get you the same answer. When you get to the answers, you should get, for part A, when we solve for this force, you should get 79 newtons. So when you solve these two equations, here and here, just plug this in, two equations, two unknowns, you should get 79 newtons. That's for part A. Part B I'm also going to do right now, but you may want to try that on your own. I'm going to erase a bunch of stuff and change one force. Well, maybe. Got to find an eraser. Oh, here we go. Here's an eraser. So we're going to get rid of this. We're going to get rid of all this stuff that's down here. And I'm going to get rid of this force of friction. And I'm going to read to you what Part B says. Part B says, what minimum force is required to start the block moving up the wall? So now we're not trying to keep it from moving. We're figuring out what's the minimum force to get it moving. Well, right before we move, we again have static friction max. So we're still going to have maximum static friction. But now it's not helping us. Instead of trying to keep the block or the book from sliding down, we're trying to get the book to slide up, or just about to get to slide up, that threshold where we go from not moving to moving. Well, if we're trying to push this thing up, friction's not helping us, it's hurting us. So friction's going to go down. So on my free body diagram, I don't have static max anymore going up, I have force of friction static max going down. That is the change in this problem. Everything else is staying the same except for the direction on this arrow. So does that mean you have to recalculate a good chunk of this? Absolutely. Because over here for force of friction static max, now this is for part B, this becomes a negative, this becomes a negative. Remember I substituted in right here, so this becomes a negative. When you're solving two equations, two unknowns, x minus y is different than x plus y. So you have to resolve with this new bit of information. Otherwise the process is exactly the same. So for part B, everything I had up here before works. It's just we solve from this point with a negative on. If you need to see the algebra, come in after school, have the algebra attempted neatly, and I'll check your algebra and see where you went wrong if you didn't get the answer I said for A, which was 79, or now with these as your two equations, and then the substitution, your two unknowns, B should work out to hopefully something more. And I say something more because instead of just trying to keep it from going down, now we're trying to move it up. That's going to require more force. So the fact that it goes from 79 to 219 seems possible. Seems possible to me, and that's what the key's got. So if you solve this, you should be okay. The important thing is that you can get to the two equations, two unknowns. If you mess up the algebra, come in and let me take a look at it. I can probably find it quickly if you have your work done neatly. But the more important thing is, can you get to the spot where it could be solved? On the test, oftentimes with this two equations, two unknowns, they won't give a point for the answer. They'll just get a point for the fact that you could have got an answer. So you got to this point and did the f sine theta, f cosine theta, and could have solved it. It's nice, though, to see it work out so that you know you did the physics right. That's it. First 4K video.
for YouTube.